Let's take a look at dividing fractions. And one very simple idea with dividing fractions is we're going to rewrite as multiplication by flipping the second fraction, taking a reciprocal of it. And at that point, you just multiply like normal. So then, multiply like normal. So you should feel comfortable with the video on multiplying fractions together before you do the dividing fractions. Well, let's take a look at a problem. And we got 5/2 divided by -8/15. Now the negative was out in front. I went ahead and put it up at the 8. It doesn't matter where you put it. We immediately rewrite it as multiplication by flipping the second fraction, taking the reciprocal of it. Top goes to the bottom, bottom goes to the top. So this becomes 15 over -8. Now at this point we want to simplify this. And this was step 1 in multiplying fractions. We want to simplify it. Doesn't look like there's anything we can do. So this just remains 5/2 times 15 over -8. To simplify, you look for a number on top, a number on the bottom, numerator and denominator, and see if you can divide both of them by the same number. Well, we got 5 and 8, 5 and 2, nothing there. We got 15 and 2, and 15 and 8, nothing there. So we just go to step 2. Step 2 says to multiply your top parts together. So 5 times 15 gives us 75, and multiply your bottom parts together. 2 times -8 gives us -16. And that's our answer. Let's look at our second problem. We've got 12/10 divided by 24/15. And again, we immediately rewrite the division as multiplication. So flip the second fraction, take the reciprocal of it, and we got 15 over 24. And then we're going to multiply it like normal. And our first step in multiplication is to look for a number on top, a number on the bottom, and that can be divided by the same number. Well, I see 12 and 24. Those are both divisible by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. So we're going to have 1 over 10 times 15 over 2. Well, we can work with 10 and 15. One's on top, one's on the bottom, and they're both divisible by the same number, 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So we got 1/2 times 3 over 2. Now there's nothing left to do in step 1. You might look at the 2's and say, well, we can simplify that. No, remember our guideline. One's on top, one's on the bottom. Those are both on the bottom. So step 2, multiply your top parts together. 1 times 3 is 3. Multiply your bottom parts together. 2 times 2 is 4. So our answer is 3/4. Let's take a look at this one. We got -3 divided by 5/6. Well, to begin with, if you're going to divide fractions, they both should be fractions. So I'm going to rewrite the -3 as -3 over 1. Whether you're adding, subtracting, multiplying, or dividing, you want them both to be fractions. Well, we never actually divide. We immediately rewrite as multiplication. So we're going to take a reciprocal, the second fraction. 5/6 becomes 6/5. Now, There is no step 1 on multiplying fractions together because I got 3 and 5, 6 and 5. There's nothing I can simplify. So I'm going to go to our second step in multiplying fractions together. Multiply top parts together. Negative 3 times 6 is negative 18. Multiply your bottom parts. 1 times 5 is 5. So our answer is negative 18/5. Okay, let's look at this one. We got 7x squared over 6 divided by 14 over 2x. And again, we never actually do division. We immediately rewrite multiplication. So this will be 7x squared over 6 times 2x over 14. Now step 1, we want to do some simplifying. Here we got 7, here we got 14. They're both divisible by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. Now we got 1x squared. We could just drop the 1. If you have 1 and then you have something else, then you never need to put the 1 down. Over 6 times 2x over 2. Well, the 2's jump out of me. One's on top, one's on the bottom, and those are definitely both divisible by 2. 2 divided by 2 is 1, and 2 divided by 2 here is 1. So we're going to have x squared over 6 times 1x, so we can just put an x. Now down here we don't have anything but a 1, so I'll leave the 1 there. Now step 2. Nothing else to do in step 1, simplifying the fractions. Up on top we have x squared, and here we got an x. And for now, we're multiplying those together. You just count how many x's you have. There's 2 x's here, there's 1 x there, so we'll have 3 x's. Down below, 6 times 1 is 6. We'll go into the property of when you got x to a power times x to a power later on. But it really is just as simple as what I just said. 2 x's and 1 x, 3 x's. Okay, let's look at this one. We've got 2x to the 4th over 3 divided by 4x squared over 9x. Okay. Never divide. We immediately rewrite multiplication. So we've got 2x to the 4th over 3 times 9x over 4x squared. And let's do a little bit of simplifying. Step 1 in multiplying fractions. We look for a number on top, a number on the bottom that's both divisible by the same number. Here we got 3 and 9. That looks like a good choice. 3 divided by 3 is 1. 9 divided by 3 is 3. So we have 2x to the 4th over 1 times 3, and we got an x there, can't lose track of that, over 4x squared. Again, we're looking for a number on top, a number on the bottom. Here's a 2, here's a 4. Those are both divisible by 2. 2 divided by 2 is 1, 4 divided by 2 is 2. So we're going to have 1x to the 4th, or just x to the 4th, over 1, times 3x over 2x squared. Now there's nothing else we can do number-wise, so let's look at the x's. And probably it's just as easy to go ahead and do step 2 of multiplying fractions together. So up on top we'll multiply top parts together. So we got a 3, here we got 4 x's, here we got 1 x, so we got 5 x's. And down below we got 1 times 2, so 2 and then the x squared. Now if you have x to a power over x to a power, we'll subtract a smaller exponent from the larger one. 5 minus 2 is 3. Write the numbers down first. Okay, 5 minus 2 is 3, and we'll have x to the 3rd power, our larger exponent was, which was on top. So that's x to the 3rd. And that's our answer. Let's look at this problem. Got 10x to the 3rd over 18 divided by 4x to the 5th over 6. Again, we never work with division, so we're going to rewrite as multiplication immediately. So we've got 10x to the third over 18 times 6 over 4x to the fifth. And let's start doing some simplifying. Step 1 of multiplying fractions. We look for a number on top, a number on the bottom, both divisible by the same number. Well, 6 and 18, both divisible by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. So we're going to have 10x to the third over 3 times 1 over 4x to the fifth. Well, I see the 10 and 4. Those would be good ones to work with. Both of those are divisible by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. So we're going to have 5x to the third over 3 times 1 over 2x to the fifth. Now, number-wise, probably not much we can do. We got a 5 and 3 here. We got a 5 and 2 here, so can't do anything else. Let's go ahead and merge this together into a single fraction. That's step 2 of multiplying fractions, and then we'll simplify the x's. 5 times 1 is 5, so we got 5x to the third. 3 times 2 is 6, and we got 5 x's, so we got x to the fifth. Okay, let me write the numbers down. Now notice we have x to a power over x to a power. So we'll subtract a smaller x1 from a larger one. So we got 5 minus 3 gives us 2. And we're going to have x to this power, x to the second power, where our larger x1 was, which was on the bottom. So that would be our answer. Let's scroll up a little bit here. And let's look at this one. We got x to the third over 10 divided by negative x to the seventh. Well, to begin with, these are not both fractions, so we need to get them as both fractions. So that's x to the third over 10 divided by negative x to the seventh over 1. Again, you can always create a fraction by putting it over 1. Never do we divide, so we're going to rewrite as multiplication. So we'll take a reciprocal of the second fraction, flip it. So it becomes 1 over negative x to the seventh. I could maybe simplify it there, but I really find it a little bit easier to merge them into a single fraction before I handle x's. So I'll multiply the top parts together. X to the third times 1 is x to the third. Bottom part, we've got a positive times a negative is negative, and the 10, and then we got x to the seventh. Okay. We have x to a power over x to a power. So we'll subtract smaller x1 from larger one. 7 minus 3 is 4. And we're going to have x to the fourth power where our larger x1 was, which was on the bottom. Now it appears that everything disappeared from the top, and it has. But when everything disappeared, you're always left with the 1. So we'll put a 1 there. And that would be our answer. And I believe that was the last problem. Yes, it was.